Hi everyone, welcome back to grade 12 Maths with Mr. Simons. We make maths easy and get your exam ready. So yeah, we're doing some more classwork on fundamental counting principle, but now we're looking at factorial notation and books. Right, so I hope the lesson helps you a lot in understanding. Right, so first I guess I have to introduce what's factorial notation. So in mathematics, the factorial of a non-negative integer, n, meaning it's positive, denoted by n exclamation mark, right? Or factorial of n is the product of all positive integers less than or equal to n. So what we mean, for example, 5 factorial simply means 5 less than 4, 3, 2, 1, right? So positive integers less than or equal to n. So 5 factorial is 5 times 4 times 3 times 2 times 1 gives me 120. Look at 4 factorial, it will start by 4 and it decreases 4 times 3 times 2 times 1 gives me 24. 3 factorial, same thing, 3 times 2 times 1 equals 6. And if I said n factorial, it would start with n. 1 less than n would be n minus 1. 2 less than n would be minus 2, minus 3, till eventually get to 2 and 1. So hope you follow. Right, then just some extra knowledge. We need to know the value of 0 factorial is 1, according to convention for empty product. So short, I can say in counting n factorial. In counting, n factorial represents the number of ways to arrange n objects. So how many ways can you arrange 0 objects? There's just one way. You do nothing, right? So that's still one possible arrangement. Therefore, 0 factorial is equal to 1 factorial, which equal 1. To reflect that there's only one way to arrange the 0 things. Right, so factorial notation, very important, is used for number of arrangements possible of one group of distinguishable objects, example, books, arrangements of words, seating arrangements, etc. So we'll be looking at different ways. In this one, we're looking at books. So if I look at the books example, high school learner has on average between, say, 6 to 7 textbooks, some even 8. They carry around each day. So in how many different ways can they be arranged on a bookshelf? So very important, there should be 7 places available to arrange the books, right? So the first book can be put into anywhere of the 7 places, right? So space 1, right? I should have written this back to front. Okay, it should read in space. First book has 7 spaces available, right? So space 1, any one of 7 books. Space 2, any one of 6 books, because now one of the 7 books was placed in the first place. Space 3, any one of 5 books. Space 4, any one of 4 books, because there 3 has already been placed. Space 5, we only have 3 books left, so any one of 3 books can be put in that place. Space 6, any one of 2 books, and in space 7, there's now only 1 book left. So number of ways the books can be arranged would be 7 times 6 times 5 times 4 times 3 times 2 times 1, as you can see there. But instead of writing that long process, we just write 7 factorial. So in your calculator, you'll press 7 and then look for the factorial sign. I think most Casios work with shift factorial, and 7 factorial would then give you 5040. So you can see there that blue book could have gone in any one of the 7 places. But once it's taken in one place, there's only 6 places available for the next book. And the next book would only have 5 places. Right, so I hope it makes sense. Right, please comment and feel free to tell me if it does. Right, let's look at the next example. Now, if you have 4 physical science textbooks, you have 3 maths textbooks, you have 2 accounting textbooks that needs to be placed on a bookshelf. Right, how many ways can you arrange them on the shelf? Right, so all in all, we have 4 plus 3 plus 2, which gives me 9 textbooks, right? So the 9 textbooks, the first textbook has anywhere but or anywhere to go in all that 9 places, right? So it has 9 options available to it. The second book would only have 8, the third one 7, and so we would go. So it would go decrease from 9 all the way to 1. So therefore it is 9 factorial, the number of arrangements, which gives me 362,880 Rand. Almost had a Zuma moment there. So yeah, we have 362,880 possible places we can put the books on a shelf. Right, now if we had to arrange the books of the same subject together, how many arrangements can we make? So this is where we're going to try and catch you out, how we change the English. So physical science textbooks, we have 4. Maths, we have 3. And accounting, we have 2. We want the same subject together. So the 4 physical science textbooks can be arranged 4 factorial ways. No? The 3 maths textbooks can be arranged 3 factorial ways. And the accounting textbooks 2 factorial ways. Right, now they didn't specify which subject must come first. So physics, maths and accounting, if we have to arrange them, we still have 3 factorial arrangements for the 3. Right, so note we have 3 different subjects, meaning we will create 3 spaces for these subjects. We have 4 factorial ways we can arrange physics, 3 factorial for maths and 2 factorial for accounting. We also need to account for the fact that the subjects can be arranged in any order. So maths can be first, accounting can be first, right? So therefore we have a further 3 factorial ways we can arrange subjects. So my number of arrangements would be 4 factorial times my 3 factorial times my 2 factorial times the 3 factorial ways we can still arrange the 3 subjects together. Alright, I hope it makes sense. Let's go to the next problem. You can pause here if you want to. Look at how it's done. Look if you can do it. But yeah, I'm continuing to the next slide. Right. Moses, a learner, has 7 textbooks from 7 different subjects. Maths, Physics, English, Afrikaans, or Maths, Physics, English, Afrikaans, Accounting, History, and Visual Arts, which he wants to arrange in a line on a shelf. Right, so in how many ways can the textbook be arranged? Question 1. In how many ways can the textbooks be arranged if maths textbooks and the physics textbooks must be on each end of the shelf? So now we're specifying what book must begin and what book must end. Right, and 3, if the maths and physics textbooks must be on each end of the shelf, what's the probability that the history textbook and the visual art textbooks are not next to each other? Right, so for the first one, they specify the textbooks. No? There's 7 textbooks, so the first textbook has 7 places, second textbook 6, the third one 5, so on. So all in all, it's 7 factorial, which then gives me 5,040 possible places or arrangements we can make for that books. Right, number 2, in how many ways can the textbooks be arranged if the maths textbook and the physics textbook must be on each end of the shelf? So number 1, they didn't specify its maths on specifically in the beginning and physics at the end. So it can be maths or physics in the beginning. So we have 2 cases, right? So if that is there, 2 books are out and only 5 are left. So the 5 in the middle would be 5 factorial and there 5 factorial, which gives me 2 times 5 factorial, which equals 240 ways. Right? So 5 factorial, 120 plus 120 gives me 240 ways. Or we could have gone straight. There's 2 books for the start, right? Times 5 factorial for the middle, times 1 book for the end, which give me 240 ways. Right, so hope you follow. So as I said, we don't know if maths or physics must come first, so therefore I have 2 cases. Now number 3. If the maths and physics textbook must be on each end of the shelf, what is the probability that the history textbook and the visual art textbook are not next to each other? Right, so number 1, if that 2 textbooks must be at the end of each shelf, that means for the middle we're dealing with 5 factorial. Right, so therefore my probability would be 1 minus the probability that the textbooks are next to each other. So we don't want them next to each other, so therefore 1 minus if they were next to each other. Right, so for the first, maths and physics, there's 2 factorial ways to arrange them. If we take that out, we're left with 4 books. Right, so times 4 factorial over 240 possible ways if you look at case 1 and case 2 for arranging maths and physics, maths and physics. Right, again, if we arrange the 2 next to each other, they can be 2 factorial. Right, so we've taken one option out of the 5 that's left there, and we're left with 4 factorial. If we say 1 minus that now, okay, I didn't put in the answer, but I'm sure you can do it on your calculator, right? But that is how we would solve it. I hope the lesson was useful. If you like, please subscribe. Right? I wish you nothing but the best. God bless. Bye.